Hello, my name is Jacob Bell and I'm a student at Marion campus and this is my second year. My topic is the effects on ocean acidification on microorganisms. I chose this topic because ocean acidification is very dangerous long term. It hurts fish and other ocean organisms. It also has a very harmful effect on the coral reefs. You might be asking yourself how I came to choose this topic. I talked to many people about the current issues and topics in environmental science today, and I came to the conclusion that ocean acidification was a great project to do because I believe that is very dangerous to our oceans and as well to us in the long term. Okay, the first part I'm going to go over is the abstract. It says, with the constant need to use energy and produce more of it, the world produces more and more carbon dioxide each day. The world's oceans absorb about 1/4 of the carbon dioxide in the air, and while this process benefits us humans, this is damaging to the life below sea level. Increasing the carbon dioxide in the world we live in requires the oceans to take more carbon dioxide than they can get rid of cleanly. The levels of pH are decreasing in the oceans, making them more acidic and potentially toxic to living plants and organisms now and in the future. In the immediate future, adding pH will temporarily help slow the process of acidification down, but the problem comes from the source. Choosing cleaner alternatives that cut on carbon dioxide emissions can be a simple thing that the common man can do, while proposing cleaner alternatives for life as a whole is a much more effective solution to our problem. Small organisms and plants are likely to suffer and die because of the mistakes made in the past, but closing in our solution will provide these living things with a future and a cleaner earth. You might be asking yourself, what is ocean acidification? Ocean acidification is caused by the atmospheric carbon dioxide concentrations rising, which change the chemistry of the seawater carbonate and also reduces the pH of the seawater. Ocean acidification is considered to be a worldwide threat to marine ecosystems because of the negative effects of the process. Changing the seawater carbonate chemistry affects how plants are able to go through their living cycles, and with carbon being more prevalent in their ecosystem, it makes it much harder to survive in this environment. Written in an article by Scott C. Doney, Victoria J. Fabry, Richard A. Feely, and Joanne A. Kelipas, they state over the past 250 years, atmospheric carbon dioxide, or CO2, levels increased by nearly 40% from pre-industrial levels of approximately 280 ppmb, which means parts per million volume, to nearly 384 parts per million volume in 2007. This data can be further examined in Figure 1. This increase in the carbon dioxide levels is very dangerous to small microorganisms living in the marine ecosystem because of their inability to survive in rapid change effectively. Okay, so the next part we're going to go over is Figure 1. So on the left-hand side of the top part, we have the CO2 levels ranging from 275 to 400 parts per million volume. And on the right-hand side of the y-axis, we see the pH levels ranging from 8.03 to 8.38. And on the x-axis, we have the time ranging from 1950 to 2020. So you can see as time has gone on, the CO2 levels in the ocean has risen as well as the pH levels, which is very dangerous to the living organisms in the ocean because as those levels rise, it makes it much harder to maintain the same living style and health levels as if it were much lower. Okay, so now we're going to go over the methods portion of the poster, and it says that many scientists have found many ways to measure the negative changes happening in our oceans today. Some of the major variables of interest are temperature, pH, O2, and NPP. These variables play big roles in preserving the lives of many organisms, especially microorganisms living in marine environments. The figure above shows the increasing levels of CO2 in the atmosphere and how it is affecting oceans' attributes. As shown, at the pre-industrial time, the ppm was approximately smaller by about 114 parts per million. Present-day CO2 is floating around 400 parts per million, which dropped the pH readings by about 1.4%. While this does not seem like much of a concern, with at the rate at which we allow CO2 to enter our oceans because of our lifestyle, it is predicted that by the year 2100, CO2 levels will rise to 1,000 parts per million. At 1,000 parts per million, the change in CO2 in the oceans would have gone up 257%, resulting in a 6% increase in the pH level, which could be fatal for fragile microorganisms and plants who are reliant on the stability of the ocean's environments. Okay, so the final part we're going to go over is the results portion. So based on the information collected, we see that the rise in the CO2 levels of the oceans is dangerous to the smaller organisms living in the oceans. The trend we are heading in is dangerous and life-threatening to these microorganisms, and a huge change must be presented and enforced to ensure the survival of these important microspecies. Okay, the next portion is going to be the data graph. So before we looked at the relationship between CO2, pH, and as time went on from 1950 to what is predicted to be in 2020. So we know that the relationship between that is a positive relationship, and by a good amount as well. But here we also see the seawater PCO2 and the seawater pH also have a portion in this graph. So we can see that the seawater pH has a negative relationship between CO2, pH, and as time went on. And the seawater PCO2 has a steep positive relationship between the variables. So now we're going to go over the conclusions portion. So ocean acidification is a dangerous process that is going on in the world's oceans today. The main causes of this is the CO2 emissions entering into the ocean and changing the pH levels as well. This change in pH causes plants and animals to live in a much tougher environment than they are used to, and it becomes much harder to survive in. Decreasing the CO2 levels we give off will help stabilize the pH levels in the ocean and give the microorganisms a safer environment to live in, as well as protect the other creatures living in there. And the last portion is the references portion. These are listed in alphabetical order, and I used 4 different sources, which gave me a huge chunk of information to help me out with this project. Alright, thank you for taking the time to look at my project, and I hope you learned something today.